Alright, for the next few problems we're going to evaluate without using a calculator. So remember, if the base and this number are the same, if these two are equal, then this answer is just 1. And why is that? Because this problem is saying 6 to what power gives you 6. And so this equals 1. Okay? Number 93, if that negative wasn't there, then the answer would be 2. But because there's a negative right here, it's saying 2 to what power is negative 4? Well, nothing. Nothing is going to make it a negative 4. Not a positive number, not a negative number, no real number will make this equation, this statement true. So this one has no solution. So this one I can use the property of logs that says that the log of the sum of the log is the log of the product. So this becomes log base 4 of 2 times 32, which is log base 4 of 64, which means log base 4 of 4 to the third, because 4 to the third is 64. This 3 goes to the front of the log, so this is 3 times log base 4 of 4, and we know log base 4 of 4 is 1, so 3 times 1 is 3. So right here, this 4 right here goes to the front of the log as a product, and so this becomes 4 times 2 times natural log of v. We know natural log of v is 1, so 4 times 2 is 8. Okay, so remember your rules of exponents and rational exponents. This natural log of the fifth root of e to the third is the same thing as natural log of, so natural log of e to the 3/5. That's what fifth root of e to the third means. So this 3/5 becomes the coefficient of the log. So this gives you 3/5 times natural log of e. Well, we know natural log of e is 1, so this is 3/5 times 1, which is 3/5. So on number 117, they ask you to describe the error. So what they wrote on the right side is what they did is they distributed the natural log to the top and the bottom, right? They just rewrote it with natural log of x squared divided by natural log of the square root of x squared plus 4. When in fact, what it is, it's the natural log of x squared minus the natural log of the square root of x squared plus 4. So that's a mistake, that they distributed the natural log instead of using the laws of properties of logs. That says that the log of a quotient equals the difference of the logs. Alright, so on 118, it's asking you to compare or to pick the two that are identical. And just by knowing the laws of the properties of logs, we know that f of x would give us the same graph as h of x, because the log of a quotient is the same as the difference of the logs. So g of x should be different. And so what I did was I made a table with x values 1 through 4, and then I made a column for each of the functions, and I took a calculator and just plugged them in. And you'll notice again that f of x and h of x have the same identical numbers, which, you know, is what we expect, right? Because of the properties of exponents, so that's what we expect to see. But I went ahead and I did the tables to show you. I know it says to use a graphing calculator, but I'll just graph it by hand right here. So for f of x, we have 1 with negative 0.7, so that would be about here. And then 2, 0, 3.4, about here, and 4, and then with 0.7, so that'd be about here. Okay, so it goes something like this. Okay, and then we have g of x, which I'll do in yellow. So g of x is 1, 0, 2, 1, 3, 1.6, which is about here, and 4, 2. So it goes something like this. And then h of x, I'll use green, and it's the same exact points as the other one, as f of x. It's the same points right here. So it goes one over the other. Okay? Alright, for 120 you have to match the graph with the equation, and I went ahead and wrote the reference points for each one with the transformation. So for the second equation, this one right here, this 2 becomes the coefficient, and so this shows that there's a vertical stretch. So the reference points from the first equation, 10, E1, this 2 right here means that we're going to multiply the y's by 2, so the only one that shows a change is the 1, which became a 2. And then this 2 right here is the b value. The parameter is b. So it's actually a horizontal compression by a factor of 1/2. So that means that the x's get multiplied by 1/2. So these 2 right here get multiplied by 1/2. So instead of 1, you get 1/2. Instead of e, you get e over 2. The y's stay the same. And this is a constant. So it's the line y equals 0.69. So that one's easy to match up. The only constant there is equation A. So this would be A. Okay? Now notice that 2 of the graphs go through 1, 0. This one and this one, right? So if you look at, that would be equation B and D. B and D. And D is higher than B, right? It's taller. So this would be D, and this would be B. And the other one, the one that crosses through 1/2, 0, that's C. Alright, so for 123, let's get rid of the parentheses and distribute the exponents. So the -3, you get 64 to the -3 times x to the -9, because remember, when it's power to power, you multiply, times y to the -12 times 8 to the 4th times x to the +12 times y to the 8th. Okay, so now I'm going to combine the like terms. I'm going to multiply those together. So this with this becomes, let me just write this, 64 to the -3rd, 8 to the 4th, and then x to the -9 and 12, that's 3. And then the y's, you add them, right? When you're multiplying them, you add the exponents, so you get y to the -4. Okay, so now let's change it to positive powers. So this becomes 8 to the 4th times x cubed over 64 to the 3rd times y to the 4th. Well, 8 squared is 64, and there are 4, right? There's 8 to the 4th power, so I'm going to say that this is 64 squared, right? Because that's 8 to the 4th power. And then x cubed. And so this is 64 to the 3rd. So then I can cross this out, and then I have, since I have 3 64s in the denominator, I crossed out 2 of them, so that leaves me with 1. So my final answer is x to the 3rd over 64 y to the 4th. Alright, for number 124, I'm going to work with the parentheses first to get a combine those or simplify the parentheses. Then I'll do the exponent out here on the outside, and then I'll deal with this. So first, I'm going to simplify this. So this is, just write this down, 1 over x plus 1 over y to the -1. Common denominator here is xy. So this becomes xy. So to get a common denominator, I need y over y, and this one x over x. So I get y plus x over xy to the -1. Now that -1 is going to flip this, right? It's going to flip this fraction right here, so I can't cancel these out and multiply them because I got to deal with this first. So this one's gonna flip this, take the make it reciprocal. So then I have xy times xy over, I'll just put x plus y, just put it in alphabetical order like that. So now I have x squared y squared over x plus y. For number 125, I could reduce the coefficients by 8. 8 goes into 24 3 times. 8 goes into 16 twice. And then I'll make all the variables, all the exponents positive by rewriting it, let's see, 3x, and then the x to the negative 3 right here, put it to the top, and then this y to the negative 2, bring it to the bottom. So I have 2y squared y. So now I've got 3x to the 4th, 2y cubed, and that's as simplified as we can do it. Alright, so 126, I'm going to flip it first because of this negative right here. So I'm going to take the reciprocal of this and raise it to the positive third power. It's the same thing. So I'm going to write 3y over 2x cubed to the positive third power. So now I get 27y cubed and 8x to the 9th.